All right, problem 4 from the free response section. We have an online game where players move through a virtual world collecting geodes. Isn't that Pokemon? Oh, it's a type of hollow rock. Whatever. When broken open, these geodes contain crystals of different colors that are useful in the game. A red crystal is the most useful crystal in the game. Of course. The color of the crystal in each geode is independent, and the probability that a geode contains a red crystal is 0.08. Sarah, well, I'm sorry about this shaking, guys. This task is, acting crazy. And anyways, Sarah will collect and open geodes until a red crystal is found. So calculate the mean of the distribution of the number of geodes Sarah will open until a red crystal is found. Show your work. Okay, so this is a geometric distribution, which is basically a distribution that describes the probability until something happens. So we want to basically find the average amount of geodes she has to open until a red crystal is found. That's kind of what we mean. That's what we mean by the mean. So this will just be, whoa, my pencil. 1 over the probability of, a red crystal being found. So 1 over 0.08, which will be like 12 or something. Oh, what the heck? 1. 12.5. And again, remember to always back your answers with logic. I mean to yourself at least, because if it has an 8%, if you have an 8% chance of drawing a red crystal, then you're basically thinking how many times we have to draw until you get a red crystal at 8%. How many 8% go into 100? And that's about 12, and that's 12.5. And you have a formula sheet with all this stuff. So know this stuff. Well, not know it, but know to use it. Know where it is. All this. So we're going to be using these formulas. Geometric. Calculate the standard deviation of the distribution of the number of geodes Sarah will open until a red crystal is found. Show your work. And there we go. Right here. So standard deviation will be 1 minus the square root of 1 minus the probability of that happening. 1 minus 0.08 over 0.08. Calculator action. So 11.99. Another player, Conrad, sounds sketchy, decides to play a game and will stop opening geodes after finding a red crystal, or when 4 geodes have been opened, whichever comes first. Let y equal the number of geodes Conrad will open, and the table shows the partially completed probability distribution for the random variable y. So this is showing the probability that he gets it on the first try, and the probability that he will get it on his second try, or not get it on the first try and then get it on the second try. Let's go to the next page. So we want to find the probability that he'll get it on the third try. So to get it on the third try means that he has to fail on the first 2 tries, which will be, since he has an 8% chance of getting it, that means he has a 92% chance of not getting the red crystal. So 0.92, and since they're independent, he still has a 0.92 chance on the second trial. But now, if we want to see if he gets it on the third trial, so that's where you're going to multiply by that 8%. Because we want a success, so to speak. So we'll do this calculation. 0.92 times 0.9. So about 6.7% chance. The probability that he'll draw it on his third try was 6.7%. About. Now the probability that he'll get it on his fourth try will be that he okay, this is where you gotta think a little differently, because here's the thing. If he hits 4, he's still gonna stop, whether or not he gets the geode. He's just, he's over it basically. So we have to calculate a sum of 2 things happening, meaning that so this is the probability that the game will stop, that he'll stop playing. And there's 2 ways that can happen. It'll be after drawing 4 blanks, missing the geode 4 times, which is 0.92 times 0.92 times 0.92, or 0.92 to the 4th. Now we have to add this to the probability of how else the game could end on the fourth try, and that's by missing the geode on the first 3 tries. So 0.92 times 0.92 times 0.92. But he could get it on the 4th try, which is 0.08. So these are 2 ways the game could end. So we just add these together. So 0.92 to the 4th plus 0.92 to the 3rd times 0.08. About 77.86%. Oops. 0.778688. So be careful about this one. That's probably the, well, this is probably the most missed one, I would guess. Almost got me, you know, almost. All right, calculate the mean of the distribution of the number of geodes Conrad will open. Okay, show your work, of course. So we're just basically saying on average, or we're trying to figure out on average how many geodes will he open. So this we just use our expected value formula, or mean value for random variables, which is this. So we just add up the sum. So we sum up the probability of getting the geode on each trial, all added. So let me just write it. The mean, so expected value. So on the first trial will just be 0.08 times 1. The second trial will be, oh, let's use our table. So 2 will be 0.0736 times 2. Plus the probability that y is 3, which is this guy, plus 0.067712 times 3, plus the probability that y is 4, plus 0.778688 times 4. And then we'll up. Where did my calculator go? Here we go. 0.08. Whoops. 0.0736 times 2. 67712 plus 0.77. 3.54. Box it. Oh no, I missed the 8. Ooh. All right, now part 2. Interpret the mean of the distribution of the number of geodes Conrad will open, which is calculated in this part. So this is just basically telling you on average how many geodes he'll select on each trial. So let's remember the long run frequency for probabilities. You want to say over many trials. We'll do 3 minis because it'll be cooler. Over many trials. Conrad will on average open 3.54 geodes on average before he stops the game. Conrad will open about 3.54 geodes on average per each game before he has to stop the game. Each game before the game is over. On average, each game before the game is stopped. Before, I assume it's some form of a game before the game is stopped. Yeah, so you want to just say that. And yeah, even though in real life you can't get 3 geodes, you can get 1, 2, 3, or 4. Like, this doesn't make sense, but you have to leave it like that, and mathematically for discrete random variables, you can still have these values. So don't worry about that. All right, so I hope that helps. I'll see you guys in the next video with the other probability free response question. And let me know if you have any questions, and please comment and subscribe, and I'll see you guys later.